You can join now. Okay. Okay. Alma's here, Marina's here, Sam's here, Annalise Cesar, she's here, Nick's here, Andrew's here, Aaron's here. Where are you? I saw him. Is Aaron here? Anik is here. Peyton is here. They left, right? Anthony's here. Anna's here. Ruel. James at the back. Gotcha. Firing on me. Huh? Yeah. Ariane. Right. Alicia's here. Rebecca. Right here. Angelo. Nadine.
This is Johnny. How are you doing?
Okay, come here. Come here. Any lessons you want to teach the class?
Mr. Glonek.
He's so funny. Why did you leave? Where'd you go? Where'd you go? Come back. They want to see you. And Granny. They want to see Granny. Taking attendance still. Kai's here. Maxine's here. Edwin's here. Matthew. Okay, done. Okay.
Can we get a picture?
I,
You're so famous. You have to get a
no,
picture.
he's trying to bug me. Just do it fast.
2 more. 3.
No, I'm closing my eyes.
2 to 1. There you go. All right, there we go. Thank you. Mr. Glonek. No.
He's really playing the part. Okay. Let's say a prayer. Pardon me? You better make sure you're going over this tonight. There's quite a bit. How many are there of you guys? How many guys? How many of you?
For what?
In the football that are in this class? Just you? Take it. We got to go over this in class. So
Right, thank you.
I can't. That you'll have to go with me in private because I can't record it. You're welcome. Let's say a prayer. Father, Son, Holy Spirit. Let's keep in our prayers. You won't remember him because you're too young, but he was former vice principal of the school. His mother just passed away. Dr. Deacon Luton's mom just passed away. So we're going to pray for her and Deacon Luton's family. We pray, Hail Mary, full of grace, Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now at the hour of our death. Okay. Let's go over page 53. Number 9. Okay, you got a physical copy of it now, so you can just flip to the page. It says, describe in words the motion of the 4 walkers in figure 310. Assume positive direction is east. High Street is normally what we'd refer to as the origin. Okay, so A is walking at a pretty fast rate. You can qualify it as fast, faster than B for sure, a little bit faster than B. Starting at High Street, walking fast. Remember, there's 3 main characteristics I want you to highlight. First one would be, in no particular order, is it constant or not? It's a straight line, so yes, it is. Straight line means constant velocity, as opposed to curve, which means changing. So it's constant velocity. Okay, next, I would state whether it's fast, medium, slow. So A is faster than B, that's good enough. It's a steeper slope, so it's faster than B. Also, whether it's a positive or negative, whether he's moving east or west. So it's a positive slope. I would put both, just so it's clear to me, you understand. If it's a positive slope, that implies east. Okay, that's what I'm looking, minimum those 3 characteristics. I'll add a little bit more to it. His starting position is at High Street. When I ask you to describe the motion, I expect those first 3. Line B. Line B is constant velocity because it's a line as opposed to changing. It is, I would say, medium, qualified as medium, at least less than A, slower than A, less of a slope, slower than A, it's good enough. And it's positive or moving towards the east. Positive slope, indicate both, just put positive, comma, east. C, I'm going to draw for you. So it looks like this. I'll draw it in green. It is not constant except at the end. Then it looks like it's leveling off. Okay, so this part here, this region here, somewhere around there, it looks like it's fairly level. If I were to draw a tangent, you recall last day I said the slope of the tangent line is, you zero in on it, draw a little bit of the curve that's parallel, or draw a line that's parallel to the curve to the right and to the left and extend it like I did. That gives you your tangent line. The slope of that is the velocity at that particular point in time. The slope is 0. So the velocity is 0. Call that the instantaneous velocity. Instantaneous. Okay, so what's happening? Obviously, in this region here, pretty constant. It's not moving, so he's come to rest. In this region, it's a curve, so it's changing velocity. How is it changing? Well, think about it. Physically, what's happening? He comes to rest here, not moving there. So he has to be slowing down. When you see a curve like this, how is it changing? It's slowing down. We'll get more into that later, but it's coming slowing down. We know it has to be changing. At the very least, I would write it when you describe it as changing. That's good enough. But just so you know, if I ask for detail later on, how is it changing? If it curves like this, slowing down. But for today, changing is sufficient. It's not constant. That's the main point. You could put not constant, same thing. Okay? Nothing more you need to add if it's not constant. Changing or not constant is good enough. I added a little bit more detail here just so you could understand it. Slope is 0, which means it comes to a stop. Be instantaneous. 0 means at rest. At rest. Comes to a stop. Okay, D. I'll draw this. I'm going to draw D. D starts here. This is High Street. And this is east. Anything above is east or positive. So you're starting here. It's a straight line. So the first thing you'd say is it is a constant slope, constant velocity. That's the first thing. Second thing. It's got a negative slope. I'm moving, you can just put east. I'll know what you mean, but I'm going to be a little bit more clear. Moving east. Or moving west, pardon me. Moving west. You can just put west. That's good enough. Again, this is no particular order. Medium, fast. I would say it's moving. It's hard to judge. You've got nothing to compare it to, but medium velocity is fine. The fourth characteristic you don't need when I ask you this question on a test, but I'll include it. Starting east of High Street. Or the origin, it's fine. Another way of saying that, starting with a positive position. Trying to lean back here so I don't put pressure on the back. Ten. Sketch the position time graphs for the four motions. A. Oh, it's too small. Starting at a positive position with a positive velocity. Okay, so let's draw our axes. This is D. This is T. I was in a little rush. I left that out, but now it's back in. D and T. Starting with a positive position, that's your origin. Anything above it's positive. Okay, so I'll start here. This will be in meters usually. So let's say this is 10 meters. Positive. It's above. Starting here with a positive velocity means positive slope. Okay, that's A. B, starting with a negative position. Could be like here, down here. Negative 10 meters. You'd start here with a smaller positive slope. So you're still sloping up, but it's less steep. I'll draw it. It's notably less steep. Slower velocity, less steep. Remaining with the negative position. So I'll write it in here. This is negative 20. Let's say you're remaining at negative 20. That just means you're standing still. You're at rest. At what? At negative 20 meters. Okay? So you can use, just so you're clear, you need to use these interchangeably. Negative implies west. And above is positive, which is also known as east. Starting in D with a positive position with a negative velocity. So I'll start at negative 10 or plus 10 again. Positive position. Negative velocity means it slopes down. Okay. 11. Oh. I bet I can do this. I bet I can take a snapshot and paste it to this. Can I do it fast enough? Let's see. Let's just take a 30-second break. Let's see if Mr. C can take a snapshot and paste it to this. I'm going to try something. Yep. No, don't do that. Can you do that in Notability? I think you can. No. Can you paste something? Yes, I can. But how do I add it to Notability? I don't want to spend too much time with this, but what's that? Okay, let's see if I can add photo to Notability. Otherwise, I have to draw it. You don't want to see me do that. Okay, good. Okay, I got it. I don't get it. Maybe I should. One more try, and then I don't want to waste your time here. Oh, add. There you go. It's as simple as that. Done. It's right. Oh. Stupid. I'll get it. I'll get it. I figured it out somewhat. Well, it's either that. I know. You know what? I should have started a new section of notes. Sorry about that. I'll be finishing it soon. Start it fresh. Okay. What's this? removed it. Come on, dude. Give me a break. This is stupid. Okay, it's not removing this. Oh, it is. Okay, I can move it. Okay. I panicked and I shouldn't have. Okay, I can do that. I can deal with that. Okay, okay. This is good enough. Can you see that? Okay, let's do it. So it says find the average. What the heck? It's upside down. Okay, find the average velocity between 10 and 12. So here is ten here. So if I extend the line up, that intersects the curve here at that point. So that's my first point. That would be what I call A. It's always 2 points. And 12. Each of these intervals here is 2 seconds. 2, 4, 6, 8, 10. So this is 12 here. Extend the line up till it crosses. That's your point B. So, not always the case, but sometimes when you joined the 2 points, it lies on the curve. Usually it cuts across, but not in this case. It lies on the curve. So the point is this: to find the average, you choose 2 points, your A and your B. You draw a line between it and find the slope of that line. Okay? So the slope, in this case, rise over run. This is 0. Oops. This is 0 here. So the rise is 5, and the run is 2. So for A, the average is just the slope of the line that connects A and B. How do you say that? Just write AB with the line over it. Which, as I said, is just 5 meters, use the unit as well, over 2 seconds. Or 2.5. Write the answer as 2 sig figs with the unit. And yes, use decimal form. Next, between 14 and 18. 14 is here. 18 is here. Draw a line up. And 14, that's your first point. That would be your C. And then from 18, draw a line up. That would be your second point. Call it D. You want a line, again, to find the slope. Draw a line that connects the 2 points. Find the slope of that line. I can just eyeball it. You can see it's 0. The average for B is the slope from C to D. Just write C to D and put a line over it. Just 0. It's at rest. How do I know it's at rest? Is the position changing? What is its position? Between 14 and 18, what's the position of this car? Yeah, 10. It's 10 at 14 seconds. It's 10 at 16 seconds. It's 10 at 18. It's not changing. It's constant. It's 10 plus 10 meters. So it's at rest. Constant position. Another way of saying at rest is constant position. At, in this case, 10 meters. This is good enough. C, between 20 and 24. Twenty is here. That's your first point. Call it E. And then 24. 22 is here. 24 is here. Right about here. That's your F. Draw a line that intersects those 2 points. In this case, it's right, lies right on the curve. Find the slope of that. The rise, it's going to be negative. Keep that in mind. So this is, what is this, 2.5 here. Negative 10 here. So negative 12.5. I'm going to write it in red. And your run from here to here, from 20 to 24, is 4. Your V average is the slope E to F. Negative, don't forget that. Did I read it right? Looks like they did it differently. Let's go back, make sure I got it right. Oh, I read it right. They calculated it wrong. Okay, so what does that work out to be? 12.5 over 4. A little bit over 3. 3.1. Don't forget the negative. And last one, 26 to 30. This is 26 here. Right, 22, 24, 26. 30 is here. Again, draw a line that connects it. It will not always lie on the curve. These are a little bit too easy. The rise is 5. Okay. The difference between -5 and -10 is 5. It's positive. And then the run again is 4. We'll label this, just for clarity, G and H. Two or three sig figs. I'm not going to get picky until later on. We'll start going back to our rules later on, but at this point, let's just focus on finding the slope. 1.25 or 1.3 is fine. Meters per second, and it is positive. On a test, I'm going to expect you to be more explicit. If I'm in a little bit of a rush, I tend to leave it out when I'm explaining it, but it is positive. Or you're moving towards the east, same thing. Whereas this would be west. Okay, Okay, so here's the offline stuff. I'm gonna have to visually explain this to you. You're gonna get a little extra practice on this. There's two sides to it. Okay, so I'll go over the first side. This is the first side when I hand it out. And then we'll flip it over to the second side in a moment. Extra practice. Hey, while I'm setting up, find the slopes. You can do this on a separate piece of paper. Find the slopes of this side, the first side, what I call the first side. This is right here. Not the squiggly. Squiggly, I'll do it in a minute. The straight line, look at all the slopes up to the edges.
Where did you put it?
Yeah. Okay, so for this graph here, they're already starting with the slopes. You're going to find the slopes, use the proper units. Remember, these graphs are just a way of summarizing movement. How far you move each second. If it's a steeper slope, you're moving faster. If it's a negative slope, you're moving towards the west instead of the east. So with this, first step was I already said, calculate the slope. Next step, same graph, write down the characteristics. 3 characteristics. Make a note of it. The characteristics are, is it constant or not? I'll give you a hint. They're all straight lines for this page. From this page first. Is it constant or not? Yes or no. Second, characterize it as fast, medium, slow. Just make a judgment call. Very subjective in some of these. Okay, fast, medium, slow. Compared to the others, it's relative to the others. How does B compare to A, right? Fast, medium, slow. Third characteristic, does it have a positive or negative slope? And make sure you indicate what that means in terms of east or west. Positive or negative slope. Add to the negative, positive, that means east or west. Okay, backside. Okay, backside's a little problematic. I should fix this and then we'll get around to it. Ignore the interval between the origin and point 2. The value per division, if you ignore that, then it works out. The value per division works out to be 0.2. Not 0.1, it's 0.2. I just started the origin in the wrong place by mistake. Okay? Now with this graph, pay attention to this because this is a little more finicky. I want you to find the average, because it's not obviously straight lines, it means it's changing velocity. It's not constant velocity. In that case, you're going to have to find the average. Find the average velocity for the following interval. Find the average for B and C. I'll write it on the board. For B and C, for BC, for CD, and DE. So draw a line between those 2 points. That's why I put a line over that. Find the slopes. That's the average. Last, that's the first part. This is the back side, right? The curve graph. So that's the first thing to do. Second thing to do, find the instantaneous. V-I-N-S-T. That's the tougher part. For C, D, and E. The instantaneous for C, for D, and for E. So that's the tougher part. Just to highlight what you need to do. Remember, you're trying to find the slope of the tangent. Which means for a curve, let's say it's only at a point. This is only at 1 point. 1 point. This is for 2 points. 2 points. You need 2 points for the average. So, getting back to the instantaneous. If you were asked to find the instantaneous at C, you would not, this is not the tangent. It will not cut through the point. That's wrong. The tangent, the quick way of understanding it is zero in on this. Zero in on that point. If you zero in on it, the curve up close looks fairly straight. So just at the point, or close to it, extend the curve. Draw a parallel line that just overlaps the curve and then extend it. Do the same on the other side, on the left side, extend it. Now, are you going to be a little bit off? Yeah, you're going to be a little off. It's very rough. But at least you'll understand what a tangent is and the importance of the slope. That ties into calculus. That's why I'm introducing it to you. You need to understand what a tangent, it just touches the curve at that point. It grazes it. Doesn't cut it. It grazes it. So on this, the tangent would be like that. I would use a ruler. Can it touch other points or on the curve? Yeah. In some cases, it can touch other points or get close to it. In general, it should just graze that 1 point. If you zeroed in on it, it would look like that. Okay? There is a more formal way of finding the tangent, but you'll learn that if you take calculus. This is just an introduction. That's all. The first part of calculus is just calculating the slope of the tangent. That's all it is. But it can get pretty complicated because you start dealing with functions and all that. Anyways, do that front and back. See how far you get today in class. What we got? I got time. We'll probably take some home for homework. Not important. Got there? Guys, for the front page, what I refer to as the front, where it's going down lines, you're trying to find the slope to any 2 points on the line, whatever it should be. Okay, I'm going to add one final point. I hope this doesn't confuse you. Remember, for the instantaneous velocity, when you find the slope, you need to draw the lines. Draw them fairly large, then you need 2 points. After you draw the line, then you could choose 2 points to calculate the slope. But not until you've drawn the line. Draw the lines first. Everyone laughs at this. They call it old tech. They tried to bully me with getting rid of it. I said no. And then guess what? Then I go to work. I usually work in the Burnaby system in the summertime, and they switch schools on me. Started working at Mountain. I'm going to put a Burning Mountain. Guess what they have in the classroom? Yeah, and I talked to them and said, I was told in my high school that this is old tech and it's bad and it's not good to
as a demo for the kids, they laugh. They said, we use Okay, so let's be clear. These are two different points or questions. Calculate the average. So make sure you write down what I want. Between B and C, average is just connecting the bottom. That's easy. The tangent, here's what I do the best of. So for C, see how there's a point there? You got the first step is to see how there's a part of the curve there? Yeah. Part of the curve extended. You turn it into a line. That's your tangent line. Then take the slope of that. That's the velocity at that point. What does that physically represent? This represents your gradient on the line. When you're looking at you notice how it changes. Yeah. So what? How does that represent on that? At each point, you have a different slope. Yeah. So that would be represented by the speed up, going down. Make sense? Yeah. Okay. So that's works. See, old tech works. I call it old tech bigotry. What do you think? No? I'm gonna get. I don't think I need to record anything more, so I can't record this part, so maybe I'll